Good evening. I'm John McAleely. I spoke here a few months ago, so thank you for having me back. I'm here to talk about over-engineering things. I've been writing a programming language, which is definitely over-engineering the problem that I've got, and I'm over-engineering building a model railway as well. But it's a hobby. It's something to do. The picture you can see is the model railway that the club I'm building is working on at the moment. It's a multi-year project. I will gloss over when we started, and I'll gloss over when we think we're going to be finished. But again, it keeps us off the streets or something along those lines. It's fun to do. Interestingly, when it's finished, it's going to look like the area of London we're in now. So it's actually based in Southwark. It's one of the reasons why I was interested in the group project when we started it. It's actually going to be familiar to people from this area. The QR code you can see is a link to the blog post, which has the slides and all the links. I'll put the QR code up again at the end. You don't need to worry about it now. Okay, so what's the problem I'm trying to solve? What am I over-engineering? I'm a member of a Model Railway Club. That's a group of about 10 of us or so, building a model railway, and we take it out to exhibitions. And for those of you who don't know, this is part of the model railway hobby where we take over a sports centre, get 20 or 30 clubs together, and we all show the layout that we've built. Usually we sell tickets and admission and people come along and check it out. And we do this 2 or 3 times a year when we have something to show. And as an idea, it's happening every weekend. There will be 2 or 3 of these around the country. And the problem that we have is you're trying to tell a story. So like I said, eventually this is going to look like the area of London we're in physically now. And we're trying to tell a story about what's going on there with the railways. And that involves moving to a sequence and talking to the people who you're exhibiting to. And if there's only one person operating the layout, that's actually quite a high workload. You're operating a complex machine that's kind of bespoke, and you're also talking to the people who happen to be asking questions. And one of the things we like to do is set up the sequence of trains coming on off stage. And that's what the picture you can see is the off stage area. And you can see a locomotive on there, and the red arrow is showing where the locomotive, this bit here, slides. And then secretly, this bit also slides. And that's what I want to over-engineer, is how to achieve that movement in an automated way. I actually gave this presentation to the club last night, and I said, you can see there it says push by hand is an option. And they said, no, it's not. No, definitely not, because of the workload, because of the need to be talking to a group of people like this, whilst also operating a complicated machine. And worrying, if you actually try and push it from hand, you spend all your time looking away from the people who are trying to figure out whether it's exactly aligned or not. It's really not ideal. The other thing I'm thinking about as part of this problem is I'm part of a team of people, and I'm the only professional software engineer. I'm the only person with the skills in that area, and I don't want to limit what I do to that set of skills. Computers can be a lot more approachable than doing it professionally, and the people in the club are interested in that, and I don't want to limit that. So that's another part of my thinking here. The other picture you can see is the underneath of the board, so the sort of underneath looking up at it, and you can see there's already a bunch of electronics on there, and that's the CAN bus, which is used in cars and other things. It's very popular on model railways these days. It's used for all sorts of things, and we use it for controlling the signalling and the point work that's operated by small motors. And so maybe we can use that as part of this solution. So that's the problem, trying to get a train to move between 3 tracks in an automated way. Okay, it's a fairly well-trodden path. There's lots of people doing this. So here's version 1. This is the simple solution. All I did here was assemble kits of parts that I could find as members of clubs I'm part of. So there's a couple of societies that provide CAN bus electronics for model railways. That's these 2 boards here. Those are CAN bus modules. This is a thing you can buy from anywhere like the Pi Hut or Piperoni. It's a stepper motor controller. This is the stepper motor that you can buy from any supplier anywhere. And this is the Pico, so we might all recognize that. This is Raspberry Pi Pico. Then the other thing you can see here is a board, which is just some switches, which provide sort of the most basic control of setting which position you want the piece that's moving to go to. So it can actually move to 3 different positions. This works. I call it simple. I don't think it looks very simple. I think it looks quite complicated. It's got 1, 2, 3, 4 microcontrollers on it. I don't know what the microcontroller here is. I know it does a lot of complicated things to do with voltages for the stepper motor. And these 2 are PIC microcontrollers, which the software on both intrigues me and worries me. It's assembler of some kind for machines that I'm not entirely convinced I understand the architecture of. And the idea of trying to customize that is a whole learning curve that I don't want to go on, and I can't imagine sending my fellow club members on. The Pico runs MicroPython. That's quite approachable. You can read a few lines of MicroPython, and once you've got your eye in, you can relate it to the problem that you're looking at. And the MicroPython on here is fairly simple. Each of these wires is one signal, and it's basically a big switch statement saying, if it gets this signal, do this other thing. Now, that is a skill to read that, but that's a lot more approachable than whatever PIC assembler is on here that's dealing with the CAN bus signals. So I can imagine my club members showing interest and being able to customize this part, but the rest is all going to be a bit of a mystery. So are there things I can do about that? It does work though. That's important to say. It does work. So the 2 big problems I want to address. One is physical size. So those 5, we don't need the switch module, so there's 4. There's only these 4 that we actually need on the layout when it's fully installed. They take quite a lot of space, and for an idea, this board is about 1 meter by about 40 centimeters, and the board with the prototype on is about 40 centimeters. It looks like there's a gap at the bottom here where it would fit, so that's great. It'll just fit. I need to put 2 on this board. Where's the other one going to go? I'm looking at this space here and thinking maybe it'll fit, maybe it won't. I actually need to build 3 of these because there's another board on the layout which needs the same thing doing. So I need to make 3 of these things. And there's a bigger truth of this kind of construction, which is if I put lots of boards on and then putting it in a car and drive it to a sports hall on the other end of the country and let it go through temperature cycles and then manhandle it and put it all the way back, something is going to break. The more I put on, the more chances there's something going to break. So physical size is important. The complexity in terms of the number of boards being used is important. And then the software complexity is just, well, yeah, this bit is quite easy to understand in MicroPython. The rest of it is all very hard to understand unless you're willing to invest a lot of time to learn what it does. And part of this is I might leave the group, or just future me in 6 years' time might want to make a change, and we'll have to relearn all of this stuff. I'm not particularly interested in that. So can I address those problems? And this is where we're already really in over-engineering territory. Like I say, we could slide this by hand, or maybe you could have a sort of simple clockwork kind of crank mechanism. We've got a lot of electronics involved already. Maybe I can do even more over-engineering. So this now comes into 2 parts. The first part is the hardware that is a bespoke design. So this board, I've actually got some with me. I'll pass them around. Sorry, the people online. Is the Pico plus a CAN bus transceiver. So it's only doing the electrical signaling for me, none of the protocol side of CAN bus. And then a space on the board for where I can put the stepper motor. I imagine this board might be a standard thing that I do several different jobs with. So this is much simpler from a point of view of hardware. It's just 1 microcontroller, the Pico. It's much physically smaller. It's about I don't know, maybe 10 centimeters square, so it will fit on the layout in more interesting ways. It is easier to understand from the point of view of approaching it. It's the thing that does the job, not the 5 things that somehow collaborate to do the job. But the software has got more complex in a different way. Now I need to run a lot more software on 1 microcontroller. Previously, I could divide the problem across 4. Now I'm going to try and solve the whole problem on 2, because there will be one on the stepper controller still. But broadly, I'm moving from 3 or 4 to 1. But I'm going to have to be a lot more sophisticated. Previously, it was a big switch statement that just reacted to the input pins and then changed the state of the output pins. If I want to talk to the CAN bus, I'm going to have to do probably use the PIO module. That's, I think, how this transceiver works. So that's a fairly sophisticated bit of hardware. I'm actually going to be doing several things at once. I'm going to be listening to the CAN bus. I'm going to be broadcasting on the CAN bus. I'm also going to be moving the motor, and there'll probably be some other things that come up at some point. So there's quite a lot of stuff going on at once. How do I approach this in a way that I leave behind software that is understandable to people who want to read it in future and make changes to it, or just comprehend what it does? I could continue to use MicroPython. It's a great language for this kind of thing. It has a feature, I think it's called async IO, if I remember rightly, which I sort of went down the path of studying a bit, which will do the multiple tasks for me. MicroPython will talk to the PIO. It can do that, no problem. But it starts being the areas of Python that you have to learn a lot about before you can use it. It's not just a question of reading the code and understanding what it does. It's go and look at this special part of the code that actually not everyone uses, that maybe you need to learn quite a lot about before you can use it correctly. And this other library that you want to use doesn't use it. It's actually quite hard to glue it all together in MicroPython. As a software engineer, I thought, well, this is starting to sound quite complex. These things are quite straightforward to program in C if you've got that skill set. Maybe I should use that. Sounds reasonable to me. And there are multiple tasks. Maybe I should consider using a real-time OS. There's quite a few of those. I quite enjoy learning what one looks like. But now I'm starting to introduce a lot of things that need to be learned before you're even thinking about the problem. If someone, even if it's just future me, wants to come along and change one variable in the future, such as the acceleration rate, I'm going to have to relearn how the RTOS works. Now, let alone someone who's less expert or doesn't want to become as expert in software. So I wasn't so interested in that. So rather than going down that path, I thought I'd over-engineer the solution and go down the path of building a language. And the idea here is, A, it's fun. Let's be honest. That's actually why I'm doing this. This is a hobby. And B, it captures the complexity inside the language in a way that becomes invisible when you're trying to read the code. So when you're reading the code, you will be reading code that looks like it's dealing with a model railway problem, not dealing with the complexity of multiple tasks and whether you're using PIO and whether you're synchronizing these things and how are interrupts on or off. None of that needs to be part of the code you read. It can be part of the language runtime and reused across many projects. I do intend this to be general purpose. It's not just for model railways. The name is the same as the cheese that you see. That's Cornish Yarg. It's a very tasty sort of cheddar-y kind of cheese. One of the reasons I like it, I like the name. Choosing the name for a programming language is hard. I found that took a while because I wanted a short name and I wanted something that hadn't been used already. And yeah, lots of awesome languages out there. One of the things I like about Yarg is it's actually wrapped in nettles. So it's transformed this thing that can sting you into something that's edible. I kind of like that. That feels about right for microcontroller programming. So I went with that name. Okay, so what did I build when I built the language? When I came here last time, I was speaking about the generic idea of building languages for Picos, that they actually have the compute power to do this, and that there are examples out there that you can just copy. So what did I actually do with that idea? So I'm a big fan of MicroPython. I think it's a great model to follow. So I've gone for the same kind of language. It's a dynamic language, so it builds its state at runtime. It provides an interpreted REPL. You can just type at it and you can say print this or look at this variable and explore into the code. And again, I think that suits the kind of learning that I can imagine someone who's interested in the problem, but not really interested in becoming a software engineer might be willing to invest. It compiles to a bytecode VM. That means it's got reasonable performance. It doesn't spend forever doing anything. It will compile and then run in a very predictable way. It provides direct hardware access. So when I was here last time, I was talking about statements that took a address, peek, or poke, and then wrote or read from the address. That is exactly what you need for registers, and my language has generalized that to give it names, so you're not just doing numbers. It also handles interrupts, so you can take a piece of code written in the dynamic language Yarg, take its address and pass it to the hardware and say, please call this when an interrupt occurs. And that's the demo I'm going to show you in a minute. And then because I don't like being sad about not being able to use things, It's got multi-core support because the Pico has 2 cores, so I want to use them both. When you look at MicroPython, it does have support for both cores, but there is an area of the documentation that says, well, we kind of added this late, and it kind of works, and kind of good luck. And it sort of works, but I wanted it to work from day one. So I'm not claiming original ideas here. I'm stealing from many, many other projects. So if you are familiar with other languages, these are some of the inspirations you would notice. So I like Lua. It's a great language for being quite small and self-contained. It's used widely for scripting within other applications. I'm not claiming it's the only thing that does bytecode VMs, but was a demonstration of how that architectural technique provides good performance. Well, okay, if it works there, it's going to work for me. MicroPython, I think, was a bytecode VM for some time, and now it's a bit more sophisticated, I think. But yeah, the idea extends quite well. Lua also has great cooperative multitasking. A lot of the problem that I want to respond to is there's a message from the network, do a small thing, and then go back to sleep and wait for the next thing. And that is a good pattern of operation that works with cooperative multitasking. It's also great for programming. You don't have to worry about synchronization. You read it, you see what it does, and you don't have to think, well, what's this other thing in the background about to do? So I wanted to steal all of the primitives they have for that. Then I also like Go. I wanted to steal its preemptive multitasking because there are multiple cores, so there will be preemptive multitasking if you want to use it. And they also wanted to steal its type system. Lua is typed, but kind of says, well, you can put any object you like into any variable. That's great from the point of view of exploring. But when you actually want to send a 16-bit integer to a register, because that's what the register requires, you do need to know that. So I've stolen what the type list from Go. And in Yarg, you can specify that a variable is a specific size so that you know exactly what will be written to a register when you write to it.
There's on your share is not working for some reason.
What stopped working?
Can you maybe reshare? Stop sharing.
I can do something. It's the best thing I can do.
Yeah.
Back, right.
They're just sort of flashing black and then
continue to share. Maybe that's a key button to press. Yeah. See how that goes.
so that's
So stealing from Lua, Go, and then MicroPython itself. Again, it's not the only thing in the world that uses a REPL, and it's not the only language that's easy to use, but they are directly used in this space already, and I want to steal from that. This is why not? Let's go to this one. So what did I actually build? 2 things. One is a piece of software that runs on your PC that produces the files that will run on your microcontroller. So it requires no other tooling once you've got it compiled, and it will produce the file that you'll run on the target device. And so that's UF2 files in the case of Picos, and other things when I eventually think about other microcontrollers. And it can also run the compiler that is part of Yarg. It doesn't today, but it will do in the future. And the thinking there is, I want to run an optimizer. I want to be able to optimize code, and I can use all of the resources of a modern PC to do that, rather than being dependent on the very extensive, but actually very small resources of a Pico. So the language compiler will run on the host PC as well as on the device. So that's one part of the system. And the other part is the implementation on the Pico itself, which is a single program called Yarg, which is implemented in C. So I'm not taking my own advice. I am writing C code rather than something else. Oh well. It provides the REPL for programming. Just checking that's not a message saying it stopped again. It provides the interpreter, a compiler, and the bytecode VM, all on device. And part of the thinking here is actually a Pico is very sophisticated. It is 200 megahertz these days. It is dual core. It is 32-bit. It has, depending on which one you use, 200 to 512K of RAM. That's actually quite a lot. You can certainly run a REPL, an interpreter, a compiler. It will do some basic optimizations in that compiler in that amount of resources. And then the bytecode VM that I'm implementing, these are slightly waffle words, I'm claiming will eventually be real-time. And by that, I mean predictable. So when an interrupt goes off, there will be a guaranteed fixed period before it's responded to. I'm not doing that right now. That's a feature for version 1 and I'm on 0.1, but I'm designing with that in mind so that the problem, it doesn't use algorithms that are unbounded in time when it could use something that's constant time. The whole thing's public, open source. I do intend this to be used more widely than just one model railway in London, but maybe not. Maybe that's what it'll be used for. But yeah, it's out there on GitHub. Go have a look. I've made a release. The release will let you turn on LEDs. I'll do another one in the next week or two with the demo that I'm about to do. So you can go check it out, and it will run on your PC, and it will also run on a Pico. Why did that not focus? So I'll do a demo, and I'll show you it live. But this is a picture to get started with. And if I can just get my pointer back, can work. Yeah. So two things about the code structure. One is when you want to respond to an interrupt, you just write a function. There's no special rules. There are no restrictions. Or more accurately, there are some, but the runtime will spot them for you and say, yeah, you can't do that. So it's either intrinsic in the language, so the compiler will say, sorry, you can't do that, or at runtime it will detect that. And actually, there aren't very many limits. And exactly what those will be will get less and less over time as I make the VM more sophisticated. But the basic idea is you shouldn't be worrying about what you're doing in this kind of code. You just write your code, run it, it'll work. And then when you want to talk to hardware, on a Pico and other 32-bit microcontrollers, memory mapped I/O is how that's done. And they're just mapped out as structures that look like C structures. So if you're familiar with a C structure, so this one in particular, perhaps worth walking through, it's called I/O Mag 0. That's the name of the thing in the datasheet. It lives at this address. So that's a memory address. And it is an array of 30 GPIO constructions that have two 32-bit integers in them, one called status and one called control. So you can directly access the field for the GPIO that you want, 0 to 30, by accessing the structures members, which makes it very convenient for writing the code that talks directly to the GPIOs. So with that, I'm now going to fiddle with my camera. This button, this button, maybe this button. Where is the, oh, there it is. Change to camera. Does it work? Does it? Yes, so you should be seeing the board. It's the lighting a bit dim. So if I, actually, before I do that, let's go back to, do you actually see both feeds? You see my desktop still? Excellent. So on my desktop, we have a serial program, terminal program, which if I connect to the Pico, apologies. Thank you. Let's see if I can change that to be sharing. Where's the share button? Oh. Maybe share. Oh yeah, that's strange. I'm sure I said desktop earlier, but computers are funny. There we go. Right. So now hopefully we can see a connected serial terminal program and a prompt. So there we go. You can see my earlier rehearsals. One from a day ago when I was rehearsing my Raspberry Pint, and then the second one, which is the South London area group of the Model Railway Society that I belong to, which was last night's demo. So I can type live, print. So, oops. So that's running live on the Pico that you see in the other camera feed. And then if I load up the button code, now when I press this button, you should see, do we see on the camera, if I can get that position right, we should see a little red light come on. There we go. If I hold my finger down, the light stays on. If I release my finger, the light goes off. So that's two interrupt events being processed, one for the down shift of the button and one for the up. So that the time the light stays on is dependent on how long I press the button. So live running on the Pico, there we go. Right, let's go to the presentation. One of these buttons is keynote. There we go. So yeah, just to run through what you saw there. This is a slightly better lit still. Has come through. Yep, excellent. Of the circuit. You can ignore all of this. That's just a reset circuit because there isn't a reset button on the Pico. All of this is just distributing power on the breadboard. That's the USB coming in from the PC. So the interesting part of these is this circuit here. We have a resistor, an LED, and over to ground from one GPIO pin for the LED. And then we have a connection button and over to positive for the button that is connected to the other GPIO pin. So the code is using two GPIOs. One, it's listening for events up and down, and the other one, it turns on or off in response so that the LED comes on. So yeah, that is the language working. And that is pretty much the end of the presentation. I've got some things to do. I didn't demo the stepper. If you were paying attention, I started with a problem and I've not actually solved it yet. I do have a working solution. That was the version 1 that the project can depend on. But well, you know, these things take time and there's other bits to do on the layout. So I've got some time. So I need to come back in a few months, hopefully, with a working stepper module. I think all of the components exist now and I've got to assemble them. The language lacks some things. Although you saw strings, there's no string library, so you can't do anything other than have a single string, which is kind of limiting. And I need to add character support, so I need to add Unicode and things like that to the language. I also need to work on PIO support. I'll need that for the stepper module. I'm actually doing that at the moment. I got that working for the first time on Friday last week. It lit some NeoPixel LEDs. And then I need to make it work on other things. I don't need any of this for the stepper control, so I'll see how far down this list I actually get. If anyone's interested in other projects or other ways of using this, then maybe they would need some of these things. Do feel free to have a chat. So yeah, we'll see how far down this list I get for the hobby that I'm building, or whether I can find other uses for this software. So yeah, that's it. So very much over-engineering a model railway problem, but with some thinking behind it. I want the code that the model railway group has to manage to look like the problem they're trying to solve, which is quite simple in their minds. In our minds, it's move a carrier into one of 3 positions, which are well known and are determined by network messages. So that's a fairly straightforward problem, but requires quite a lot of sophistication to solve on one board with hardware like the PIO to drive to do the network messages. If you're interested in Yarg the language, I have a newsletter. Please feel free to sign up. It's hiding behind the QR code if you want it. It's not the QR code, takes you to a blog post and you can follow the links. The sources, if you're interested in those, are on GitHub. It's MIT. Do what you like with them. If you're interested in model railways, feel free to check out our website. We are the South London Area Group. There are area groups all around the country of the Scale Force Society. So yeah, open to questions or ideas and suggestions for what's next. Thank you.
Very good. It's like Yarg is an awesome name for it, but you're always thinking, yeah, they're what? Very good. And realize, or geez, could be another railway group or something.
Could be. There are several uses out there on the internet already. Yet another report generator is out there. So I think if you're a Java programmer, I think you'd recognize.
Just be naughty.
Absolutely. Yeah. I'm going to have to do one talk like this where I bring some cheese along, but
I love cheese. It's one thing I didn't quite understand. So the Pico board you had, the board that you had.
Yep.
So that could actually control the stepper now, but your language can't. Is that what you're saying? Like the hardware works, but you're still.
Yes. The short version is that the hardware works, and as ever in projects like this, the software is running much later. So I have a working board. It could do exactly what we need. But I'm over-engineering the software and it's still coming together because I can't actually control all of the parts of the Pico yet with the software. That's what's actually missing. I'm kind of working down a list of all the things that Pico does, and I haven't got to the pieces that I need.
If I walk up your Pico and start programming microphone, I thought I could do the job.
Yes.
But not stuff, not the way you want to do.
Absolutely. So MicroPython, you could do the job, and for my taste and my taste only, the complexity you'd see in your MicroPython is not kind of the way I wanted to take the hobby that I was spending time. But yeah, you could absolutely do. Absolutely.
It makes sense.
As in, where do are you familiar with stepper motors?
Yeah, I don't understand how that fits in a long railway.
Right, okay. Let me show you. Let's go back to the picture. So the question, here we go. Maybe the previous.
I'm looking at that, I don't understand, does it operate twice?
Yeah, so what it's actually operating is this piece here. This is a carriage which can slide in this dimension. And then when you look at the prototype, if I can get the focus to be in the right thing, wrong one, next, there we go. This piece of, I'm going to put my point, this piece of wood here is attached to the piece of track and moves in this dimension. So the track would be attached to this and moves. This is very much a prototype of a software engineer who doesn't really care about whether the trains move or not. Yeah, that's the idea.
Per set of points, essentially.
Yeah, per moving track section, and we've got 3 of those on the layout. Yes. 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 And in fact, this is exactly possible for a hobby because we're using parts from the 3D printer industry. Yeah. Literally, we're getting a stepper motor and mechanism delivered at the moment from, I think it's somewhere in China, that is from exactly that industry. And it costs not very much compared to what we're spending on other parts of the layout, 30 quid or something.
And in that picture, the 2 chips on the right, the canvas chips, those are sending, receiving back.
Yes, yes. So technically the CAN bus is these wires here, so that's where the voltages live, and these microcontrollers are watching those voltages and turning it into digital packets. Yeah, absolutely. And then signals on these wires here. Yeah.
What does your group think of this whole thing?
There's a mixture of interests. There's some people who are like, this is more interested, more advanced, or more, I'm trying to think of a good word, more sophisticated than they want to spend time on a model railway with. But as a group, we're quite interested in what kind of show we can put on. And over time, this is going to enable quite sophisticated options from that point of view. So we're all kind of interested in to see where it's going to go. We'll be able to tie together things like the display you see, explaining what the movement is, the lighting sequence on the layout, so that it's nighttime and daytime, and all of that will be controlled by modules that are being driven by CAN messages.
Yeah, that's one of the questions in the chat.
Okay.
Stable. Just we're going to control the trains and things like that with.
Sure, let me see if I can bring the chat. Right, so the first question is, how does it integrate with the trains to control the trains? This piece of the puzzle is not. It's adjacent to that, but our CAN bus system, yes, absolutely, contains messages that are speed and direction for the trains, yes. If you're familiar with model railways, the actual protocol on the track power is called DCC and is another bus protocol. It's separate from CAN, but yeah, our CAN buses drive with the trains. Could you elaborate why you are moving the train rather than switching points? Mostly it's a space consideration. Points are actually quite expensive in terms of length, and we want the overall length of this to fit in the back of a car once it's been broken down into smaller modules. So it's a space-saving thing, is why we want to move with sliders rather than points. If I had taken the MPA Sync.io route, would your area group users have needed knowledge to alter the framework or just the routines? I think a bit of both. They wouldn't actually need to worry about how async.io works, but they would have to learn about async.io, how to use it. And that is not in day 1 tutorials for MicroPython. It's quite a long way down the path of learning MicroPython. And so it would be an interesting experiment to go down that route, I think, and see how successful it was. But I talked to quite a few people who are interested in this space, and there's definitely a divide between people who are happy to look at a page of Python and understand how it relates to model railways, and people who are usually referred to as, yeah, they're a professional C programmer and they've solved the problem in a more sophisticated way. But then it's not touchable by anyone else. And that's not desirable from my point of view.
John, can I add a word to that?
Yes.
Um, you said they would need to understand a bit of both. Um, they'd have a number of routines that you've provided to do the task you're focusing on.
Yes.
Um, what exactly would they need to understand about the framework section?
I think the thing they need to understand about it is how it can be used, in the sense that it's not universal. It's not universally used within Python. So if you took another example, like you felt, okay, I want to change this a little bit, I'm going to add a routine that's going to turn on a light so that we know when it's moving, for example, and I need a library for that. Maybe that library will be aware of the async IO, or maybe it won't. And you would need the knowledge to understand, do these things connect?
Yeah.
And maybe that's not in, maybe you were thinking more about the implementation of async IO, in which case, no, you don't need to know that. But you do need to know how to glue them together. And that's definitely not beginner MicroPython.
Lovely, thank you.
So you think you can achieve with this that you couldn't with, say, some well-crafted MicroPython libraries that you could import, that you could just use?
I think the main problem with going down the route of building MicroPython libraries is there's already something that almost does what you want. So why aren't you using it? And so if you build a whole new thing in MicroPython, it's going to be duplicating an existing library, except for just one thing that's a bit different. And well, maybe you should try and modify the original library. Fine, but am I going to fork that, or am I going to try and work it upstream? It's quite complicated. So I think the answer to your question is you could do it going that way, and there's nothing uniquely you can't do, but I'm hoping the path is easier. I think that's where I'm going. Is there's some initial complexity up front of writing the runtime. Hopefully, part of what I was talking about last time is how that's getting a bit easier, and after that, it then becomes an easier path to. I'm willing to find out.
Is there a lot like competition between the clubs? Like you're going to go for shows, it's a sports movie, you're going to have like the best training and everything.
Sure. The official answer to that is no, there is no competition. The unofficial answer is there is always a vote from the public who got the best layout. And of course, there's some underlying, well, that's interesting. What are you doing there? Why are you doing it that way? So the answer is yes and no, or no and yes. Choose which order you want to say that in.
Of course, it's competition, it's all a bunch of nerds.
Some of that, yes. Yes.
I'm just as a thought, it feels to me like using a Pico is like if you used a normal Pi and ran on containers, but you'd have far more ability to kind of host it on one.
Yep.
Is it just a preference for using Pico's ESPs, whatever?
It's partly that, and that's partly a sort of an element of pride on my part. There's a lot of compute in a 02W, which would be the smallest kind of multitasking thing I would think of using. There's a lot of compute in that, and what we're doing is actually very simple. We're turning a few lines on and off. There's a lot of complexity hiding behind that. So part of it's that, and then the other part of it is actually a popular choice. And if you go to a model railway show, you'll find a lot of Raspberry Pis hiding under layouts, and they're all put together that way. And it comes with a set of disadvantages that I'm interested to see if we can do away with them. One is they're quite fragile in the sense that if they don't boot up at the right time, if they're turned off at the wrong time, if the power goes down in the hall and you need to turn everything on again, or if the Raspberry operating system has been recently updated, you meet a layout where there's some people scratching their heads and they're trying to figure out what's gone wrong. And if the right people are there, then they solve the problem. And if they're not, then sorry, this bit isn't working today. Whereas a self-contained microcontroller doesn't have that set of problems. You do have to solve all the problems to get to that point, but once you've got it on there, it works forever. So I think it's a valid approach. Yeah, why not?
Or is it kind of seen or something?
Yeah, it is a popular choice. There's a widely used package called JMRI, which runs in Java and does model railway automation.
I've value for them both at home.
Okay.
If you create your own Docker instance, yeah, you kind of casting in stone the dependency. You're less susceptible to
Cool.
patches.
Yep. Yeah.
So it's, kind of de-risk yourself on that side.
Yeah. I suppose for my analysis, it's close to the same problem on the microcontroller where I was thinking, well, do I need to use an RTOS? Do I need to use Docker containers? You know, would I just use the Pi and its OS, or do I need to add Docker containers to make it manageable? Fine, now I need to know how Docker containers work, or anyone approaching the system needs to know how they can't just use stock Raspberry Pi knowledge. It does work though, it is widely used.
It's a good way of packaging something.
Yeah, okay.
She knows kind of keep a very high probability of.
Yeah, okay. Yep.
How do you find them? Is it? Yeah, Dockers that are essentially working forever and don't really have any problems at all.
Seems to be, I mean, I haven't had any problems when you do like and also the other thing is now with all the Python libraries, is a lot of them you have to run in a virtual environment.
Yeah.
You can't, unless you do the forced override, but then you've got a chance of screwing up your main nodes.
Yeah, there's a reason why they're stopping you from doing.
Yeah, they started in bookwork basically. And so either you run in virtual environment, but then if you have something that you're wanting to run, let's say as a service,
Yeah.
you either got to run it in a virtual environment as a service, or run in a container, which is the hell of a lot easier. And then you just have a container, you can see all your containers, what's running, set it to auto restart, and it's actually very low admin.
Yeah.
And you can have loads of them run. You know, if you've got 4 gigs on a Pi 5, you can have 20, 30 of that.
Okay, cool.
I guess I have to move forward in what way I do things. Still doing.
Well, it was a little bit time for me, so but I was getting sick and tired of having these
Oh, yeah.
services that were running, which were dying, not restarting, and then you kind of, it's quite hard to see whether they are or aren't running. But in Portainer, it's very easy. Got all your services, don't all your containers run and see what's running.
I see another question online. Are all the tracks powered? This is starting to be a model railway question. There's some good forums out there, of course. Or only when they're lined up with the main track. Don't know yet. We were actually discussing that last night in the club, what we wanted, because there's pros and cons to both approaches. Yeah, we still to be decided is the answer to that question. And then perhaps more interestingly for this group, when the system is powered on, does it know the position of the driver, or does it need to put one power on? It's actually something I noticed my laser cutter doing is at home. So it sort of runs the head to one end and sort of bounces it against like it's trying to go in that direction. What I learned as I've been researching is that's a behavior to zero the stepper driver and know where it is, and then predictably go to all the places it needs to go. So I think the answer to the question is we're going to have that behavior. So when you power the layout up, it's going to go to a known spot, go, okay, I'm at 0 now, and then be able to move to wherever it needs to go.
Can I ask a question? Which
Yes.
I'm not really familiar with model railway. So your use was thinking in terms of this thing as a kind of carousel for delivering locomotives.
That's not a bad way of thinking about it.
Those are triggered by events and times, for example, or just times.
The choice to move to a particular location because you want that locomotive at that time will be an event on the network. So there'll be a sort of stream of events on the network, say move to this position, now move to this position, now move, and we'll probably have a button that's for next event, next event, next event.
And then the locomotives can also be taken into this thing.
Yes.
So
Yes.
Like sits in the wings and
Yes, yes, yes.
so would I suppose a sort of table arrangement wouldn't be easy to reconfigure to as the network changes, is that?
Part of the assumptions we can make is that our network is very stable over time. So as we build the layout, it sort of grows a bit and then it's going to stop. So we'll settle on a particular sequence of operation that we use every weekend when we show it.
You wouldn't hide all this, containers, RTOS
Yep.
stuff from the user and
Yep.
thinking, I want my locomotive to arrive at this time.
Yep.
And I want one to disappear
Yep.
this time.
Yep.
And so I can't visualize, maybe because
Yep.
of my shortcoming
No.
presentation.
Yep.
What it looks like.
That piece of the puzzle is separate to this presentation. And then, so I was saying there were standard CAN modules from a society that does CAN bus for model railways. They have modules that sit on the network that are driven by text files or that are driven by a panel of buttons that you build that for exactly that purpose of saying, okay, I want the next point in the sequence, the next point in the sequence, or if the sequence has reached this point, do this and this. So that's a kind of separate module on the system.
So that isn't part of the reserved words of your invented language.
No, entirely. That's part of the network packet spec. Yeah.
Cool. Thanks very much. That was very unexpected.
Thank you.